All right, so I'm going to close my Android Studio project here, and let's go into the assignment.
Whenever I use my link for Blackboard, I get that same error.
Yeah, I've been getting it a lot lately.
Why is that?
I don't know. It used to be that when you were timed out, it would automatically take you back to this page. And then I see this a lot, but then if I click this, I think it'll work.
Huh.
So something's going on with their timeout, dealy, flippy, majiggy, thingamabob. All right, let's see, a couple things before I forget. So I think I do not have self-assessment template up right now, because several people asked whether or not that was required.
You don't have the streaming lectures up right now.
So basically, I'm unprepared, is what you're saying.
I was just bringing out.
I was kind of slapping this thing together. Let's repair a couple of these things. I just figured that you all would do what I was thinking, not what I said. Seems like a reasonable. Let's see. I think I do this as a blank page. Self-assessment. Then I paste that in there and submit. Okay, so that's self-assessment stuff. And then we need lectures, right? And then do we need slides? We need slides. Oh look, I haven't even shared it. It's complete incompetence. All right, anything else I'm missing? Covers everything? You can see how long that took, so I have a good excuse why I didn't do it. Worst part is you could see that I had typed those things for other classes, so literally I put you as a low priority. So I've done it for I assume all my rest of my classes, but there's maybe another one that slipped through the cracks. Okay, so let me do this. Let's go to assignments. I'm going to pretend like I'm you here for your homework. And so I'm going to go here to, well, actually, I could probably just copy it from here. All right, so I'm going to grab that GitHub link. All right, so we're supposed to do add front and remove front. So I'll open up Android Studio. And what I'm going to do here is, actually, hold on. So we're going to check out a project from version control right here. We're going to do this from GitHub. All right, so it wants to know my repository, so I'll paste that in there. It wants to know where I want to put it when I'm done, so I'll just throw this on my desktop for now. And this is what the directory name will be, so I just hit clone, and it goes ahead and it checks it out. See, would you like to open it? Yes. Okay, so let's see, details. Cannot find module. Two modules cannot be loaded. You can remove them from the project.
up by important.
By who?
You gotta close all of this and import the project again. So Gradle will build it again.
Okay, so actually let's just do keep all. And pop this open. All right, so, well, do I have to import it again or just reopen it?
Yeah, import it from wherever GitHub.
I got to do what I just did a second time?
Yeah, but just import, not check out.
Well,
So close this.
well, let me try something here real quick first. So I want to do, so I don't want to import from. Okay, so this is the one on my desktop.
Yeah, import projects.
Yeah, but that's, all right, so you checked it out to the desktop, then you imported it.
Yeah.
That's not the way it should work. So this is the project I just checked out. So I'm going to go ahead and, it looks like I was doing the other one on the desktop too, but so this is the project I just checked out. Unregistered VCS root. Center Git, but it's not registered in settings, so let's add root. Let me do something else here. I'm going to open up the original project. That's this guy. Let's go to VCS. All right, so I'm going to say commit changes. I'll say initial commit. All right, leave it like that. I wonder if I committed it wrong. So let's do a commit and push. Okay, so it says push was successful. Let's get rid of that. Let's go out to my desktop here real quick. We're going to delete this guy. We're going to pretend like that never happened. And I'm going to go back and I'm going to do this again. So we just opened up Android Studio. We're going to check out a project from version control, GitHub. And I'll paste that in. We'll put it on the desktop. We're going to clone it. Yes, I want to open it. Okay, well. So that's linked list IML. If we say remove selected, what does that do for us? Okay. All right, so let's try this again. All right, so let's check out a project from version control. Oh, actually, that might be interesting. So not that. Check out. I wonder if there's something specifically wrong with GitHub. What if I use Git instead? Give it the full thing. Let's clone it. All right, so you did not say yes here, right?
What? Oh, no, I think I did.
All right. All right, so same problem there.
Let him now that because it's saved locally, so then from there I just
Right, so what he said he had to do was he had to then import the project, right? So he then went to desktop, went to the project, this guy, and then imported it, which forces Gradle to build it.
Yeah, that's what happened on mine. I don't know if I did that exact thing.
I'll just command it.
Okay, yeah. So this is just because we don't have a local version control for this. So this is as if you just downloaded it, and now you're saying, do you want to have version control for your own version of this? So we'll say add root, so that'll build version control for it. And this is the project. Okay. All right, so I mean, this is fair enough, but why wouldn't it be able to open the project directly from GitHub? So you can check it out, but then you specifically have to import it. Is this a problem with how I'm going to try this again here? Let's do a search here real quick. Android Studio, GitHub, checkout, Gradle, build. Yeah, so this is what you said, importing it. Building the local repository word. Oh, well, so all the solutions seem to be just to import it. All right, Android Studio not recognizing Gradle-based projects. So maybe it's a new version of Gradle issue. Remember last time I said I was testing something because it was just a new version of Gradle? Download, unzip, choose the current project, file close, pop OK. So that's the same solution we had before. Are these all recent? When was this guy posted? Oh, so that's not the new version of Gradle. Well, I guess I don't have a great answer for you other than what he suggests as a solution. Check it out. Don't open it. Then, so I guess this would be the official steps. We'll do the official steps here. So we're gonna move this to trash, except I'm actually gonna move it to trash. So we're right here. We'll go ahead and check out a project from version control. We'll choose GitHub, paste in the link to it, choose where you want to put it, clone it. It asks us if we want to open it, say no. Then import project. Browse to the thing on the desktop, hit OK. and this does the Gradle build on it. It forces a Gradle build on it, and then you can choose to file this under your own local Git repository so that you can push it to your own account on GitHub. So we'll add root here, and now you have a project. That make sense? All right, so that appears to be the checkout process. Now the flip side process to this is, let me see if I can fake this. So I'll go to VCS. So the problem is, since I pulled from my Git repository, is it going to think that it's the same thing? So let me make a little change here. So here we'll get rid of this. I didn't like that comment anyways. All right, so now we'll go back here. We're going to do commit changes. We'll say made a change. So we'll go ahead and it's going to say commit and push. But the question is it going to let me?
Even before that, you have to select where you want your Git.
So underneath here, is there a settings? Or is it a Android Studio setting?
Or it was in the VCS menu.
VCS menu.
For add. Unless it was already there and I didn't realize it.
Okay, so under Git, clicked add. See what that does. Is it thinking? I don't think it's thinking. All right, well, okay, so this will be fine. So what we'll do is we're going to say, because the very first time you do this on Android Studio, it's going to ask you to log into your GitHub account. So you have to put in your username and password for GitHub when you push it, I believe, right? Everybody have that experience who pushed it to GitHub? It's, at some point, it's going to ask you for your account. The problem is it's already asked me for my account on here, so I'm trying to fake it as if it knows who I, well, I guess as it, so it doesn't know who I am. So we'll go to VCS, so you could actually create. So we're going to say import into version control here. So this is how I pushed it to begin with. So when I originally pushed it, remember last semester you actually went into GitHub and you created a repository, then came back here and actually did all the stuff from the command line. You can actually do that entire process from within Android Studio here. So I'm going to import into version control. You can share project on GitHub. All right, and it's telling me the project's already on GitHub, but for you, it would ask you the name of the project and it would put it into your GitHub repository. And then you can just copy the link. It actually will give you the link back once it's done. So if I click GitHub here, it takes me right to the link. So it'll, that's what you'll submit for your homework solution. Just copy this link and paste it in. Does that make sense? All right, so that will allow you to create your own local repository because you're not going to be allowed to push to my repository. So you can't accidentally do that. Because I haven't set you up as a collaborator on this, I have 0 contributors. You can't accidentally mess up and overwrite my project. Instead, what you would have to do is create your own GitHub repository, which is a copy of mine. The alternative is what you could do is you could actually go to the link here. Let me just sign in. This probably won't work for me on here either. But if I was on one of you, actually, let me go to a different person's account so I can show you what I'm trying to do. So I'm going to go to this guy right here. So this is a different project. I'm set up as a contributor on this anyways, but I think what I can do is I can click on fork, and it's asking me where would I like to fork this repository. So I have a couple of different accounts on here. So you could go and fork my repository into your account, which would then create that repository, and then you could check it out from your account directly rather than checking it out from my account. You'd still have to go through that same process. So the difference is do you fork it first, which creates a GitHub repository on your account, then check it out from there, and then push or commit your changes and push the results back to GitHub? Or do you check it out from mine, make your changes, commit those changes, and then import it into GitHub, which would then effectively do what forking did here? That makes sense? So that's kind of the process. Okay, so let's go back here. Let's delete that guy just so I don't have multiple copies of this dude floating around. So I'll move this new one to trash because I already have my local version of this, which just happened to live in the same exact place. Okay, and let's go ahead and run this. So for those of you who are having issues with this, just go ahead and try to submit it sometime today through GitHub and make sure it works and all that jazz. So let's go ahead and run this real quick, and we already have a device running. Okay. Let's see kind of where we left off. If I remember correctly, we have stuff displaying out to the console but not showing up in the app yet, right? That's kind of what we were working on at the end of class. All right, so whatever, this is all doing that. And this guy seems to be flipping out here, right? Is that from so many checkouts and stuff? Let's just do this. Let's kill Android Studio. Let's reopen Android Studio and see if we can get it to stop flipping out there. Okay. Oh. It's just weird. I'm just going to show, I think it'll just be, is that info? Or is it debug? Might not actually make a difference. So right now in our main activity, when this guy launches, I'm creating a new linked list. I'm telling that linked list to display itself. That's this guy. And display should, what, just say empty list right now? Yeah, system.out.println empty list. I did run it, didn't I? should launch the app here. Main activity. Sure it does. Let's kill off that guy. All right, now let's try launching it. I think I had the old crashed one was blocking this. Com example, that linked list. Let's look in this guy. List. That all looks fine. This is what looks funny. Why is it trying to... Here's the package name, which is fine. Here's the main activity, which should just be off that package name. Let's clean this project. Now let's rerun it. Process of installing in theory. Okay. There we go. All right, I'm not sure what broke in it, but the fix, and this is kind of a common fix in a lot of applications, is go up to the build menu and just do clean project. That'll uncompile or pretend like nothing's compiled at this point, and then allow Gradle to rebuild the entire project. I don't know if this was something that screwed up with all these checkouts and things like that, but in any case, this guy seems a little funky that I have that, but let's just do a search here for empty list. There's my current output, empty list. All right. So let's go ahead and let's kind of go down the line for our homework assignment. And let's get it outputting here at the console for a starting point. And then what we're going to do is we wanted to actually use our Android interface for showing the contents of the linked list as we're seeing. Looking for stuff inside of this output channel is going to be a bear because we have all this extra crap going on. All right, so going back into our linked list here, we were supposed to write, what, add front? All right, so this guy takes a string as a parameter, and let me, see, I'm going to do that. That should give us some more space. All right, so this guy takes a string as a parameter, should build a brand new node. So we wrote this node class last time. A node can be built using a string. By default, it sets the next node to null. So remember we were talking about this last time, kind of drawing this picture. So when we bring a brand new node into existence, so technically these are strings now, so it's the string 12. All right, so when we bring a brand new node into existence, we set this node's payload to 12, and its next node by default is set to null. All right, so that's the very first thing we need to do when we're adding something to our the front of our list. We need to build the package that we're going to add to the front of the list. Okay, so before we can deliver it to our list, we have to box it up, kind of like Amazon. All right, so right off the bat, in add front, we're going to say node n is equal to new node, and this guy takes a string as a parameter. We happen to have that string right here called value that was passed in. Somebody's going to call that. We'll see that here in a few minutes. All right, so this guy builds a node around the value that was passed in, and right now that node currently points nowhere. Now what we ultimately want to do, following our pictures, is if our, let's assume our linked list currently looks like this. What we want to do is we want to make our brand new node, in this case this guy's name is n, so here we'll even name him. So in code I name this guy n. We want to make this guy's next node point to the same place that head points to. Now head might point to null already. It might point nowhere, so in which case we kind of wasted our time, but they'll still point to the same place. And what I'm getting at there is if I drag this out of the way, and this is actually what my list currently looked like. That is, I had the empty list where head points nowhere. And I want this guy to get added to the front of the list. The very first thing I would do is I would have n point to the same place head points to, which is what it already pointed to. It already pointed to nothingness, okay, to null. But now we've guaranteed it points to null. Once we've preserved the place that head points to, in this case that's a waste of time, but in this case it would not be a waste of time. So once we've preserved the place head points to, then we can go ahead and make head point to our new node, which effectively adds it to the front of the list. Make sense? All right, so that's the two moves that we need to do. So go into our code here. So the first thing we're going to do is we're going to say n.setNextNode equal to head. And I like to say this dot, just for whatever. So you remember up here in our linked list, head is a node. It's a pointer to another node. All right, so this is saying I want n's next node to go to the exact same place that head points to. So head is a pointer. It holds a memory address. If we were to print out head, we would get a node memory address. All right, because head points to a node. And now I'm going to make n point to the same node that head points to, because n has within it a variable called next node that's of type node. This is another node pointer. All right, so we'll go back here. So we have our brand new node, set our node to point to the same place head points to, and then we'll say this dot head is equal to n. Then we can make our head point to the front of this new list, or this new node rather. All right, so that should be it for our node. Now if we go back to our display method here in linked list, so this guy up here, right now my list would not be empty if I actually had added something to the front. So we can go ahead and do this in our main activity. Right now we're creating a brand new linked list, then we're telling that list to display itself. And then I can say ll.addFront. Let's give it the string 1. And then we can do ll.display like that. When I display it the second time, that is, when I display it when this dot head is no longer equal to null, my code currently doesn't do anything. So instead, what I needed to do is I need to tell a linked list how to display itself if it has stuff in it. Okay? So what we're going to do here is we're going to teach a node how to display itself. So public void display. So we're keeping this within the text world here, not putting it into our Android interface yet. We'll do that here in a few minutes. So public void display. So we're going to teach a node how to display itself to the screen. So what a node will do is it's going to say system.out.print this dot payload, which is going to be a string, concatenated with, let's maybe just give it this this arrow. Okay, actually, let's do this. Let's just print out the payload on a single line, and then we'll ask the question: if this dot next node is not equal to null. So if this particular node actually has a next node, that means we're going to go ahead and say system.out.print space arrow space concatenated. Well, let's just do that. And then we're going to tell this dot next node to display himself. So how does a node display himself? Well, he'll always display his payload, regardless. Then if he happens to have a next node, he'll go ahead and display a nice little arrow because it's a linked list. Okay? And then he will ask his next node to display himself. So it's kind of a chain reaction. A node talks to the next node, tells him to display himself, who talks to his next node, tells him to display himself, so on and so forth. Okay? So that's how a node can display itself. So now back in linked list, if we're not dealing with the empty list, how do we make the list display itself? We just say this.head.display. We tell the first node to display himself, and he knows how to display his payload and how to possibly, if he has a next node, tell his next node to display himself. So we just start the chain reaction here. That make sense? All right, so now we should be able to get a list that says 1 with a, actually this will just say 1 for right now. Let's go ahead and run this again. So we'll know, well, we will see empty list once because we do print multiple times. So in our main activity, we create an empty list, then we display it, so we'll see empty list. Then we add something to the front of that list, and then we tell the list to display itself again. Is this guy running yet? Let me kill off my iPhone simulator there. Kill off that server there too. Seems to be surprisingly slow launching. There we go. All right, so we should be able to see empty list in here somewhere. There's our empty list. Actually, I'm just going to do a search for that. That should give us all of our outputs. Is that not true? Here's our add front, takes in a value, sets that, creates a node, sets the node's next node to head, then sets head equal to this guy, so head's no longer null. So that means when we call this here, so this puts a breakpoint in. So I'll pause the application here, so just to make sure we're getting into display. So I'm going to go ahead and when you want to run it through the debugger, you hit this little dude up here that looks like a bug. So I'll hit that guy. See, I wonder if we actually have to do a final println in order for it to work. Just make sure it gets to this part of the application. Why is this running so slow? Just for sanity's sake, I'm going to change this to a println. We used to not even be able to do a system.out.print on Android. We used to have to do this log.i whatever to make this work. So let's just do printlns. It'll put it on different lines, but next thing I'll end up doing is just killing off my emulator and restarting it, because it's usually not this slow on this machine. That took forever to start launching. So we'll definitely restart the emulator after this run. Alright, it's up now. So I should be able to see. Yeah, there's the one. So it must be that only printlns are acceptable for the alternative is there's a thing called log.i, and then we can give it a string tag and then our message. So I can give it like linked list output, something like that, and then the message can be this dot payload, something along those lines. It wants me to resolve symbol log. It's fine, so let me import it. Alright, so I imported log. That's this Android util log. So this is the old way of doing this. What's nice about this is it gives us this tag to use to do a search in here. Okay. Relatively unimportant for us because here pretty soon we're going to be looking at all of our stuff through the interface as opposed to searching for it through text. But couple of versions of Android Studio ago, they started supporting system.out.println, but apparently not system.out.print. All right, so before I do anything else, let me kill off this run of the application. Did it already die off? Maybe when I started typing stuff, it killed. All right, now it's dead. I'm gonna quit this emulator here, and let's just launch this program one more time, and we'll launch this emulator, let it go ahead and do its reboot thing, and hopefully it starts running a little quicker. And then we'll write add end, and then we'll start getting stuff showing up in our emulator. Actually, let's get it showing up in the emulator first, because we started that last time. Just so we can get away from this. Oh, Android is upgrading. Beautiful. I think full functionality. It's an Android phone, yeah. It says it launched. Oh, I just need to unlock the phone. There we go. All right, so this guy's running now. So let's go ahead and let's start getting some stuff spinning out to the screen. So last time, if you remember, we did a little experiment here inside of main activity. I commented some stuff out here where we created a view, we went through and we inflated a layout, and then we added that to our scroll view. So we had this scroll view guy here. So what we want to do is when we build a linked list, we want to pass it the scroll view, and we did that. All right, so we want our linked list to kind of have that container it's going to use to throw nodes into for us to display nodes. All right, well, what does it mean to display a node? Well, a node looks like this. We create a brand new view. We inflate into that view this node layout. So that's what a node looks like. Okay. And then we just added it to the subview. So right now, all of our nodes, I think we just hard code a value into them. Let's see. Here's my node layout. Yeah, so now right now they all say 15. So let's go back to our code here. And we'll revisit this stuff here to see how this works. So let's just do 10 of them for right now, just so it launches a little quicker. So we get a view, we go ahead and set this view up, and then we add it to our subview. Now what we want to do though is we want to look at our node XML, and we want to look at this label, and we call this the value TF. Okay, so this is a text field that lives in there. So what we're going to do is we're going to go ahead and get this text view in our code. So we'll say text view TF is equal to v dot find view by ID r dot ID dot the value TF. All right, and this guy is going to be a text view version of that. Like that. And now we can say tf dot set text and the text we're going to set it, let's just do the empty string concatenated with I. So it should be 0, then 1, then 2, then 3, so on and so forth. Then we'll add that subview in there. So now instead of having 10 15s, we should have a 0, then a 1, then a 2, then a 3, like that. So let's just make sure that's working, because this is effectively the functionality we need for a node to display itself on the screen, right? We need it to be able to set that label. All right, that launched a little quicker. All right, so there's our 0 through 9 for our nodes. Okay, so having said that, in order for a linked list to display a bunch of stuff, it needs this scroll view. All right, in order for a node to display itself, it has to create a view like this, grab the text view associated with that view, and then set the text to be the payload. So what I'm going to do here is I'm going to steal this code here, and we're going to go into our node class, and where we're currently displaying our output right here, we're going to do this the view way. All right, so when a node is asked to display itself, it's going to go ahead and it's going to create a view. We'll call it V, and so we'll import that. Now, right here, this guy needs a layout inflator. The problem is that he doesn't have a layout inflator. All right, because this guy is not an activity. This guy is a plain Jane Java object, okay, who do not have layout inflators. So for the sake of convenience here, what we're going to do is we're going to go into our project, and would you say that we have, potentially, we're going to have a whole bunch of node objects inside of our project here, right? As our list gets bigger and bigger and bigger, we're going to be adding more and more nodes. All right, so what strategy is a decent idea for us to share something like a layout inflator, okay, share some resource across multiple objects? What strategy do we use to do that? Started talking about it last semester when we were talking about design patterns. Which design pattern lends itself to that? Okay. Making what public? The layout inflator? What am I making public? Okay. What were the 3 design patterns we talked about last semester? Singleton? In this conversation, that's the only one that matters. But we talked about Singleton, MVC, and Observer. Okay, those were the 3 we talked about. Okay, what's a Singleton? We used it last year in our Dungeons and Dragons cave crawler guy, right? Okay, what is that guy? What are Singletons used for? Would a reasonable answer be they're used for this? this problem right here? Okay, so the idea of a singleton, remember when we first introduced it, was let's say that a bunch of us are sharing a car, right? And rather than one person holding on to the keys, instead we pick a single location, maybe this drawer over here that we're going to keep the keys. And when you need the car, you'll check the one place where the keys live. And if they're there, then you can use the car. If they're not, somebody else has the car. So we can create a singleton object and from our main activity, toss that guy the inflator. We can toss that guy the scroll view. So all the pieces that any of our nodes need to display themselves can be up in this single singleton. So now this guy here, this node, when he's trying to display himself, instead of saying this dot layout inflator, which he's not an activity, he doesn't have a layout inflator, he'll instead talk to our singleton and say, hey, will you toss me the layout inflator? I'm going to need it for a minute. All right, and he'll grab that from the singleton and use it to inflate this view. That makes sense? Okay. Similarly, you can also ask that dude for the scroll view, which means that our linked list no longer has to take in a scroll view as a parameter. Now, having said that, there's a little bit of danger to doing that. So I think we're good with our layout inflator for right now. And we could do it with the scroll view for this example, but let's say we had multiple linked lists and we wanted each of these linked lists to display themselves in a different scroll view. So maybe I have 5 scroll views on the screen and I want one linked list to use this scroll view, another linked list to use this scroll view, another linked list to use this scroll view, so on and so forth. There's a little bit of danger just throwing my, quote, single scroll view up into the singleton when a single node doesn't necessarily know which scroll view he's supposed to access. That make sense? So with that in mind, it might make more sense for a linked list object to be built in terms of the scroll view in which he's supposed to display himself. That's kind of how we're doing it right now. If we go back to our main activity, when we built our linked list here, we told him about the scroll view that he is supposed to display himself in. Similarly, we could also give him the layout inflator, right? But layout inflators are kind of universal. Think about a layout inflator as being like a air pump, all right? So if you have a lot of different things, if you do water sports and things like that, and you're pumping up boats and inner tubes, and you do sledding and all that stuff, so you have all these different things you might pump up, air mattresses, that kind of stuff. You could have a single pump at your house and use it to pump up all sorts of different things, right? It's kind of the idea of you get one of those Coleman pumps, right? Well, same thing would be true here. A layout inflator is like a pump. Okay? Doesn't matter who gave it to us. We don't need 30 different pumps. We just need a layout inflator that knows how to pump up layouts. All right? And he's going to pump it up for us, and then we're going to take it and add it to whatever view we're interested in adding it to. So it's reasonable for us to put that layout inflator up in our global singleton, because it doesn't really matter which activity we got it from. It's an inflator. It's a pump. It's our Coleman pump for pumping up beds and boats and whatever else we wanted to pump up. So let's go ahead and let's create our singleton here. So one thing I think is in here is I think we can actually generate a singleton. Did Eclipse have that last semester too? Okay. I don't like using it. Okay, I think it's stupid the way they implement their singleton. So I'm not going to use their singleton. What they do is they actually generate a single instance, and you always have to ask for that instance. It's like 2 steps when you can do it with one. So I'm just going to create a blank Java class here. And we're going to call this guy list core, because I like to put the word core with all my singletons. It's maybe a good way to just recognize it as a singleton. So we'll hit OK. So here's our, yes, I want to add this to my Git repository. So I just told it to remember that from this point forward. All right, so here's my list core. And, oops, sorry. So inside of here, I want to go ahead and I want to give myself a layout inflator. So if I go back to main activity, this is where we got our layout inflator. Okay, so we're going to go ahead and grab this guy and set him into a variable up in our singleton. And let's find out what kind of animal that guy is. This .get layout inflator is a type layout inflator. So we're going to create a variable of type layout inflator in our core. So we'll go up to list core. We're going to create a static variable. Then we can make this public. By default, it would be a package level, but whatever. So static layout inflator. So let's just call this guy inflator. And notice it went ahead and imported it for me, so I have access to that guy. And then we'll go back to our main activity. So now what I can do is, as part of our setup here, I can go ahead and we'll just do it right up here at the top. I can go ahead and say list core dot inflator equals this dot get layout inflator. Okay, so I went ahead and I gave myself, I went to Walmart, I bought an inflator, and I threw it up there in our singleton. Make sense? So now I have access to the inflator. Now, what we're going to do here, though, is we're going to still build our linked list. Yeah, let's do it this way because I want to show a point. We're going to still build our linked list in terms of the scroll view that we want it to display itself in. Okay, this way we can have multiple linked lists displaying themselves in different scroll views if we were interested in that. All right, rather than throwing our scroll view up to our Singleton and then having to have our linked list kind of remember, well, the scroll view I'm supposed to use is called Scrollview 1. And this other guy says the scroll view I'm supposed to use is the Singleton's variable called Scrollview 2. Instead, let's just build our linked list in terms of the scroll views that they're supposed to have control over. All right. So back to our node. Our node is trying to inflate itself, but he doesn't know how to get an inflator. So instead, we're going to say list core.inflator. So he went to the garage, grabbed the inflator, and now he can blow up a node. All right, so that's what we just did there. Then we'll go ahead and grab the text field from that, that node. And we're going to go ahead and set the text in that to this dot. Actually, it's already a string. We don't need to concatenate it onto the empty string. This dot payload. All right, and we're no longer going to do this system out crap. That'll make our life a little easier. So it created our node as a view. It went ahead and grabbed the text field, set the text field equal to the payload. Now the last thing it needs to do is it needs to add this view as a subview to the scroll view associated with this linked list. Now our display here does not know about that scroll view, but our linked list took in as a parameter this linear layout. All right, so it knows about this layout that we're supposed to put stuff into. So what we're going to do, we're going to go ahead and do this. I'm going to grab this code here. If we're dealing with the empty list, I think last time we were going to kind of make a fake node. This time, why don't we just go ahead and just build our node object or our node layout and use that. So I pasted it in here. It wants to know, do I want to import this crap? Yes, I do. So I'll go ahead, and if it's the empty list, I'll just go ahead and create a view for my layout. I'll grab the text field, and I'm going to set this text field to just say empty list. All right, now I need to add this guy as a subview, just like we did out here in main activity. So we're going to take our list view and add as a view to it v. I'll steal this line. We'll go back into linked list. And we'll go ahead, and this guy's not called SVLL here. Instead, it's called this dot layout. That is the layout that this linked list should be adding things to. And in the event that it's an empty list, we'll go ahead and just create a node layout for us and set the text in it to be empty list, and then add it to that guy. Otherwise, we're going to go ahead and tell the first node in our list to display itself. But what we're going to do now is we're going to pass this guy this dot layout. We're going to give that display method the layout in which we want that node to display itself. All right. So now we'll go back in here to node, and now he needs to know that he's going to take in a linear layout as a parameter. We'll call it layout. All right, so lastly, we'll go ahead and paste this in, but it's called layout.addView. All right, so when a linked list is told to display itself, it's going to go ahead and say, well, if I'm empty, I'm going to go ahead and just add empty list to my layout. If I have stuff in my list, what I'm going to do is I'm going to ask every one of my nodes to display themselves, and I'm going to pass them the container in which I want them to throw their visual representation. Okay? So does it make sense why we made this guy something that linked list passes to the nodes as opposed to making it a singleton? The singleton, we gave ourselves the global inflator that we can use to inflate any layout. But in this case, we want a node to make sure he displays himself within the container that this linked list was built to fill. All right. So now nodes know how to display themselves in terms visually. A linked list knows how to display itself visually. It either does it as the empty list, where it just creates a node layout, or it goes ahead and asks the first node to display itself visually, passing it the layout in which it should display. Now let's go back to our main activity here. So we'll go ahead and take, I'll just comment out this code again. That was just for testing. All right, so we'll go ahead and create our linear layout that we're going to use to build our linked list. Now, for right now, I'm going to comment out these 2 lines. So we'll go ahead now, right now it's an empty list, so we'll go ahead and tell that list to display itself. So what we should see on the screen is a single node that just says empty list. Go ahead and run this. There's our empty list. Okay. Similarly, if I add some things to the front, let's add several things. 2, 3, 4. And now we tell our list to display itself. This will actually be the list 4, 3, 2, 1, right? Because we keep adding these to the front of the list. Okay. So let's go ahead and run this. And now we'll see that each node tells the next node to display itself, and they display themselves in terms of the linear layout in which they're supposed to display themselves. What row? What row? Oh, hold on a second. I don't think we finished writing this for node. We didn't. So this is how a node displays just itself, and notice this guy's never talking to his neighbor. So we now need to ask if this dot next node is not equal to null. If I have a neighbor, then go ahead and say this dot next node dot display, giving him the layout in which to display himself. We deleted it when we took the text-based output out. So now when a node displays himself, he takes care of displaying himself first within the layout. Then he says, do I have a neighbor? If I do, then go ahead and ask him to display himself, and I'll go ahead and hand him the layout that in which he's supposed to display himself. Now it should show us all of our nodes. Four, 3, 2, 1. All right. Make sense? All right. So now let's go back to our linked list, and let's write the other function. So now a linked list knows how to display itself. We've written that ability into our linked list. So now we're going to write remove front. So we weren't supposed to do add in. We were supposed to do add front, remove front for the homework. Okay. So this guy is supposed to remove and return the node from the front. So what does that mean? If my list looks like this, and I want to, and all these are strings, by the way, and I want to remove and return this guy, what I need to do is I need to create a separate pointer we call this guy node to return, and have him point to the same place head points to. And then we can update head to point to his own next node. And then we can set node to returns next node equal to null. So we officially disconnect it from the list. Okay? So that's our moves there. So very first thing we'll do here is we're going to say node to return is equal to this dot head. All right. Then we can ask the question, if this dot head is not equal to null, that means if it points to a real thing, because we don't want to start calling functions on something that's not something. Right? So if this dot head actually points to something real, which in our example here it does, it did, it still does, but it looked like this. So the very first thing I did is I created this new variable and made him point to the same place head points to. Now we could be in an empty list situation where we just made both of these guys point into oblivion. Okay, it might point nowhere. But we made him point to the same place head points to. Then if head is a real thing, then we'll set head equal to head's next node, which may or may not be a thing, but at least we have a variable called next node. So now we'll say this dot head is equal to this dot head dot get next node. All right, so we'll update head to be the new front of the list, which might now be empty. Then we'll say node to return dot set next node to null. That's this move right here. And finally, we can return node to return because we've disconnected it from our list. Make sense? So now we can go into our main activity. We're going to add some things in here. Then let's just do a ll.remove front and then tell it to display. So now our list should be 3, 2, 1 because we added 4 and then we removed it from the front of the list. Okay? So we should see the list 3, 2, 1 now. There's our 3, 2, 1. All right. Now, for right now, we have to do all of our moves before we actually display it because if I tell this guy, let's do this. We'll display it there. Then we'll remove front. Then we'll display it again. We're going to see that we're adding it on to what's already there. We're not emptying out our function yet. So let's go ahead and run this. So we'll see. We'll have 4, 3, 2, 1. Then we'll have 3, 2, 1. Four, 3, 2, 1. Then 3, 2, 1. We just kept adding it on to what was already there. Now we could do this. We can go into our linked list, go into the display function, and we could say this.layout.remove all views. So every single time we tell a list to display itself, we'll start off by emptying his layout, but then we'll never see that intermediate step. We'll never see the 4, 3, 2, 1 followed by the 3, 2, 1. Because the 4, 3, 2, 1 will be immediately removed when we print it out the second time. Does that make sense? All right, so I'll push this to GitHub. So your homework for next class is, if you will, finish submitting homework, the homework that was due today in case you were having GitHub issues. But your homework for next class is to write add end and remove end, those two functions. So now you're going to have to traverse to the end of the list and then add something there or remove something there. Okay, so now we can see that we just have our final result here. So what I'll do is, just for right now, I'm going to leave this commented out just so you can visually see all the kind of the progress as you add and remove stuff. You'll just see them keep adding on to the list. All right, we could always put like an empty node, I guess, if we wanted to. In fact, here, I'll just do that real quick for us. And you could take off. I know we're out of time. So then we'll put a little divider line in here. So that'll divide up our sublists for us. So I'll always do that at the end of a list's return there. All right, I'll see everybody on Thursday. Yeah, there's our little sublist divider. Beautiful. All right, so I'll go ahead and push this.
Thank you.
Oh, okay.
You get to sign. Oh, you need a pen?
Yeah, thanks.
Thanks. So that makes sense.
Okay.
When you explained the assignment, that
Okay.
made a lot of sense.
Okay, good.
So I feel like I'm just not. I'm not comfortable writing the code yet. Still.
Well, and that's normal.
Yeah.
That's still normal. You're more comfortable today than you were 2 weeks in last semester.
Yeah.
Okay, so in 3 weeks you'll be more comfortable than you are today. Just got to keep hammering at it and do your little study group stuff again. And
My study group is ditching me now because they're too busy.
okay, well, so maybe try to create a different group, a subgroup or something like that, or maybe talk to some of the upperclassmen or something. Say I'm looking for somebody to help me with 300, so you can meet with somebody to kind of give you a little hand holding as you're going through the stuff.
Mm-hmm.
But everybody in here is doing the same assignment, so it seems reasonable to me that that somebody's going to be interested in working on homework together. So just put a post out there on the 300 Slack, and I'm sure you can get a group of people together.
Okay.
Sound good?
Yeah.